Now, you've looked at subnetting, and I don't know if you've noticed that all your subnets have to be the exact same size. So once you start borrowing host bits, so if all of a sudden I borrowed 2 host bits to give me 4 networks of 62 usable addresses, if I just want to send data between 2 routers, I would have to be wasting 62 usable host bits in that design. Well, variable length subnet masks is a way to use all the addresses available to you in your subnet mask without wasting it. So it's just a way of organizing the way to allow you to maximize the use of subnet. Now this video goes into some of the basics. I'm not going to play it. I'll let you watch it if my computer will. Here's an example. But basically what I want to do is look at what I'm trying to do. We're trying to conserve addresses. Now, granted, IPv6 gives you a whole lot larger stuff, but let's just look at the example here that I've got 4 buildings, various number of hosts with routers in between each of the routes. And when I look at, in a perfect world, I would want to create a design that just gave me just enough IP addresses based on the number of hosts I'm trying to serve, with probably maybe a little growth, so you got a little bit of growth in here, so you're not redesigning your total IP structure all the way through. So when you're looking at, I'm looking at how many networks do I need and how many hosts am I trying to create. So I'm trying to create a subnet mask to only give me the exact number of hosts I need. So if you looked at the basic scheme, it would say here, we started off with a class C /24 network. And you go, oh, okay. So, but if I did a /24 network, what would that mean? I would have, I would use 0 addresses 0 to 255, where only 2 of them are, you can't use the 0 bit, you can't use the 255 number, so you end up having 254 usable hosts. I could waste, if I only have 30 usable hosts in my network, why would I want to use 254 of them and throw away, 220 some odd IP addresses? So the basic concept with VLSM is I organize the subnets I'm trying to engineer in sequence, largest to smallest, so that I can see what do I first need to borrow to fit my largest subnet. So basically I'm subnetting the subnet. Basically what I'm trying to do here is, so I had 254 possibilities. When I looked at the scheme that we had up above here, it says, well, I got 30, I got 25, 20, 15, and 28. So I'm going to take building D is my largest need. So the question is, how many bits would I have to borrow to handle 28? Right? But you're also looking at how many networks do I need, because I'm borrowing bits. I'm trying to get number of networks. I'm trying to get number of hosts. So when I looked at the maximum number of hosts I need is 28. what if I looked at that magic number? So it started out with 128, 64, 32. Well, 128 is wasting too many, 64 is wasting too many, 32, I got 30 usable hosts. So that means, hey, that looks like the perfect candidate for me to borrow that many bits to make sure I can build subnets to fit the maximum number piece. So that's what we do. We says, I borrow, since I'm looking at the size of my host, you say, okay, does it give me 32? Then the next question is, how many networks do I have? Well, I've got one for each router. So you got building A, B, C, and D. And I've got the connection between the different routers. So there are 7 networks that we're dealing with. 7 broadcast domains, right? Remember what a router does. It breaks up a broadcast domain. So when you look at between router 1 and router 2, there are only 2 hosts. There's only 2 network connections I got to worry about. So I want to make sure I don't waste anything. So I've got 7 networks, and I got 28 hosts I've got to manage. The perfect solution for that is to borrow 3 bits. So that gives me 3 bits. 2 to the 8 gives me 8 subnets, 0 to 11111, and it gives me 2 to the 5th minus 2. I can't use the network and can't use that. It gives me 30 host bits. So all I've done is I've organized my networks in such a way to make sure I know what's the largest one. I need to borrow a max of 30. So I'm going to borrow 3 bits, and my first 4 networks are going to be my buildings because they manage the largest amount. So I've got /28. Now I look at it and says, okay, now I've got my 4 networks. So I got network 0, network 32, 64, and 96, which takes me down to network 128. So all my stuff up between 0 and 127 are used in my 4 building. Now I'm looking at what is my site-to-site network. What am I connecting? Now this /27 says, oh, I'm still wasting. If you wanted to subdivide this again, you could. You can do small enough, but it basically says, since I have 8 networks, I give 1 to each one of my network connections, and then I still have 1 left because I've got 8 and only had 7 that I needed. I probably would have changed that a little bit to minimize the number of addresses I'm wasting between networks, but this just gives me an equal distribution across all of my networks, and all my addresses are the same. But if I look at this same thing and look at how many unused networks I've got, I've got quite a few unused networks in my subnet. Now, in the first 3, not a big deal, right? I'm wasting 2 addresses, stuff, but it's between the 2 routers, I'm wasting 28 addresses. So if I'm wasting 28 addresses plus time, so I could be wasting 84 network addresses. So the question is, if I wanted to reduce the number of subnets available and maximize, to minimize how much wasted stuff I'd use, what would I do? I mean, I could do it this way, divide it 1 time, keep everything the same, everything would fit, but I'd have wasted a lot of space. But since I'm subnetting the subnets, so to speak, I could start with 7 of them being identical and then subnet that last octet into smaller segments and look at that to try to find, how do I get down to this? It basically says what? If I look at how many hosts I need to borrow 2 bits, gives you 4, and what's that? Gives you a /30. So I could take that last octet, change that to a /30, and then put those connections to be identical. So if we look at this, I'm going to now take, here's all my 4, evenly distributed, and that last octet, we're going to subdivide that again. We're going to subnet that again. Instead of borrowing 3 bits, we're going to borrow on that last octet, we're going to borrow a total of 6 bits. So I only have 2 usable hosts, so I'm not wasting anything else. So basically all I did was take that last segment and subdivided it and kind of subnetted the subnet to make that so that I'm going to have more non-wasted space when I design this. /30 is perfect when I'm talking about being router-to-router communication, because it's 2 to the n minus 2. Since I only have to worry about 2 additional host bits, subtract 2 gives me I'm only using 2 hosts. So in a perfect world, I'm only going to engineer, so variable length subnet mask allows me to subnet the subnets. So the biggest trick of variable length subnet is to organize your needs in sequence, largest to smallest. And then as you go through and say, get to a point, I've used up the biggest block, and then that last block available, subnet that again to minimize how much stuff, meet that network. So I'll let you go through a couple of examples and how to do this, especially when you look in here, you're looking at what? This /30 gives you 2 addresses that's usable. So that's the key when you're doing router-to-router. The buildings, you just got to look at how many bits am I borrowing based on the max size that I'm looking for. In this case, they didn't tell me how many. But, 25, 20, 15, the same numbers again. But it basically saying I'm just going to, that last segment, so I'm submitting the last segment and give me that. So I'd have you go ahead and do this practice. It'll be highly beneficial to you. If I need to go through another one, I will. And let's just see here what else is left in this thing. So let me stop here, and then I'll go in the last segment, talk about structured design.